So we're just going to be reviewing, getting ready for our test tomorrow. I'm going to talk through basically the different things that you're going to need to know on this quiz. And then we'll go through an example problem of each type so you can all see how it's done again, kind of refresh your memory. And then there is a short 10-question math-based assignment that is a review for the quiz. It is due tomorrow, and the reason is that doing this review will be very, very helpful for you taking the quiz tomorrow. So everybody needs to try this review assignment. I'll give you plenty of time to work on it in class today. But if you can do well on this review, then you're going to be doing well on the actual quiz as well. So let me take attendance really quick, and then we'll get started. But I'm going to go ahead and pull up the page of things you want to know for this upcoming test. And these are the 5 main things that you want to know. So let's see, Ace is here. I don't have Phoenix yet. Is Justin Morales here? Yep. Okay, cool. Should be everybody. So the things we want to know are how to graph a line. I put 3 exclamation marks by this because this is probably the most important thing. If you can't graph a line, then you're probably going to struggle with this. You're probably going to struggle with this, and you're definitely going to struggle with this. So graphing a line is the most important skill to have for this upcoming quiz. If you still don't know how to do that, you need to stay after class today and get some practice and help with it, because that's going to be the most important thing. Next up is how to calculate the slope of a line from graphs, and then how to calculate the slope of a line from 2 points. So hopefully everybody has this formula written down. You're definitely going to need it. I'll have it up again on the slide where we're going over this. But this is the slope formula. Everybody needs that somewhere because you're going to need to use it on the test. And then how to solve a system of equations by graphing and how to solve a system of equations by substitution. Those are the things we've been working on the past couple days. Substitution especially is the one we've been working on the past, like on Friday and then yesterday. And that one, a lot of people haven't done the IXL or the math space for that yet. And it is giving people trouble. So please make sure you do that before tomorrow.
Okay,
yes, Todd?
Are the y-2s at the bottom of the equation supposed to be x's or y's?
That's an x. My handwriting's bad. I'm sorry. Those are x's. So it should be y2 minus y1 over x2 minus x1. But I'm going to go over that again in just a second. So these are the 5 different things that we want to know. So we're going to look at some example problems for each of these types of problems. So first off, we want to graph the line y equals 4x minus 6. So everybody should be able to tell me at this point, what are the things I need to do to be able to graph a line? What do I need? Oh no. You're all scaring me. Please tell me I'm just missing chat. You do need a line. What do you need to actually draw the line? I need something to plot, right? I need to find an x and y. Specifically, I need to find 2 different points. So you should have steps written written down for this somewhere. You're going to start by looking or calculating 1 point. And to do this, you're going to choose an x value. So does anybody have an x value they want to pick?
0.
Okay. Pamela said 2, and then I heard Todd said 0. So we'll use 2 and 0. So for our first point, we're going to plug in 2 into this equation. So y equals 4. And then again, wherever we see x, we're just going to replace it with a 2. So 4 times 2 minus 6. Then we solve this for y. 4 times 2 is 8 minus 6. 8 minus 6 is 2. So y equals 2. So we've got our first point. That is 2, 2. We can go ahead and plot that right over here. Then we're going to plug in 0. So we have y equals 4 times 0 minus 6. 4 times 0 is, of course, 0 minus 6. And 0 minus 6 is negative 6. So now we've got another point here. 0, comma, -6. So we go to 0 and then drop down to -6. So our line should look something like this. And yes, I am aware I can't draw straight lines, ha 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 ha, but you get the point. So everybody in this classroom should be able to do this at this point. If you can't do this, please stay today and get some help from me or Barb, because this is really, really important. And this skill isn't just important for this upcoming test. This is going to be something you need to be able to do for the rest of high school math as well. So if you're not sure how to do this stuff yet, then that's something we need to get some extra practice in. Moving on, determining slopes. So we want to determine the slope of this graph over here. Does anybody remember what we want to do in order to determine that slope? There's something we need to do first.
Yeah. Count out the y and then count out the x.
Count out the y and then count out the x for what?
Okay. Yeah. So you count up the y until you can get like a solid number, like a whole integer, basically.
Okay. So yeah. So the first thing you want to do is pick 2 points that have like solid integer numbers. So like I can see this hits at an intersection of 2 lines, and then maybe here. These look like 2 solid points. So I'm going to pick 2 points. You could have picked any 2 points, so we could pick a point down here if we want to. We could pick a point down here. We could pick a point down here. It doesn't actually matter which 2 you pick. You're going to end up getting the same slope. What is slope equal to? What do we often call slope? I know there's the formula, but what do we more, I guess, colloquially? That's kind of a fancy word. What's one of the terms that I used for slope a few times? Does anybody remember?
Intercepts.
Not quite. So I'm thinking rise over run. So this is our change in y over our change in x. So from here, all we have to do is count out our change in y. So in this case, we're going to go up 1, 2, 3, 4. So our change in y, or our rise, was 4. And then we calculate our run. So our change in x, we go over 1, we go over 2. So we have 4 over 2. 4 divided by 2 equals 2. So our slope here is just 2. And no matter which points you chose, this one, you would go up 2 and over 1. That's still going to give you 2. If you had chosen this one, you'd go up 6 and over 3. So you'd still get 2. So all of these different cases, you're always going to get the same slope. Remember, though, it's really important that you always take your points from left to right. And if you go down, so for some, if the line was like this instead, this is not a straight line at all, but that's okay. If the line was like this and we were going from, like, let's say this point to, I don't know. Wow, okay, none of these are points. Whatever, we'll pretend this is a point. If I'm going down, remember that that's a negative number. So make sure you're paying attention to whether your line is going up or down. Really quick, as a check-in on slope, this line we know has a positive slope. We just calculated this. What does this line that I'm drawing have? Assume it was actually straight. What's the slope?
Undefined.
That one is actually 0. So Pamela and Asa both said 0. This one is 0. The undefined one is one's going vertically. And here's why that is. So if we look at this, the horizontal line, the one going left to right, our rise is 0. And our run is whatever you want it to be, right? Like from here to here, we've gone up 0, we've gone over 3. So our m equals 0 over 3, which is just 0. This one, though, let's say we pick this point and this point. We go up 1, 2, 3, 4. So our rise is 4, but our run, our left to right distance, is 0. And you can't divide by 0. So that's why we get undefined on a vertical line. And then lastly, what is the slope of this line? Positive, negative, or 0 or undefined?
Negative.
Yep, it's negative. So remember, if the line is going down, it's negative. If the line is going up, it's positive. If it's horizontal, whoops, that's horizontal, I swear. It's 0, and if it's up and down, it is undefined. Pretend that was actually vertical. Okay. if you have questions about that, again, you're welcome to stay after class today. I'm going to give you guys plenty of time to work on stuff. All right, so using the slope formula, I gave it to you here again, but it is m equals y2 minus y1 over x2 minus x1. If you don't have this written down somewhere, you're definitely going to want it before the quiz tomorrow, so I would strongly recommend putting it somewhere you can remember it and have it for tomorrow, because you are going to have to use this. So we're going to use the slope formula, m equals y2 minus y1 over x2 minus x1, to determine the slope of the line that goes through the points 2, 5, and 740. So first of all, what's the first thing I need to do to use this formula? Does anybody remember?
Pick which one's y and pick which one's y2 and pick which one's y1.
Yeah, so we're going to pick which point is point 1 and which point is point 2. Usually it is easier to use the smaller x number as your point 1. So we're going to call this one point 1, and we're going to call this one point 2. So if this is point 1 and this is point 2, m equals, what is my y2? Which number in here is the y value of point 2?
Is 40.
Yeah, it's going to be 40. Then what's y1?
5.
Yep. Over. Somebody that isn't Todd, what is x2? Yep, good, Jennifer. 7. And somebody that isn't Todd or Jennifer, what is x1?
2.
Yep, good. It's the 2. So then we're going to solve this out. 40 minus 5, that's 35. Over 7 minus 2 is 5. So our slope is 35 over 5, and 35 divided by 5 is, of course, just 7. So our slope in this case is 7. And again, if this is something you're not sure about how to do, make sure you stay after class, get some help, get some practice. This will be on the review one as well, so as long as you can get through it there, you should be all right. Okay, now we get into the 2 harder ones. So graphing systems of equations to solve them. So first of all, everybody hopefully remembers that if we have a system of equations, so if I have 2 lines like this, and let's say like this, the first thing that everybody should know is the solution to this system of equations is the point that they intersect. So right here. You can think of it as like a pirate. X marks the spot. So what we're going to do is we're going to graph both of these lines, and then we're going to solve the system of equations that way. So I'm going to pick a different color for my first line. So we're going to do this line in green, and then we'll do the second line in, what color do you guys want? I know it doesn't matter, but blue. All right. Do the second line in blue. Okay. So just like we did before, what's the first step in graphing this line? What do we need?
You want to solve for y or x?
We want to solve for y, but we need to choose an x. So we need to solve for 2 points. So we're going to pick 2 points. Somebody give me 2 x values, please.
0 and 1.
0 and 1. Todd picking the easiest ones. All right. 3 and 9 wouldn't fit on my graph, Pamela, but you could pick those. So we'll do 0 and 1. So we're just going to plug in this. We're going to start with the 0. We're going to just plug this in wherever we see x in our formula. So y equals 4 times 0 plus 2. 4 times 0 is 0 plus 2. And 0 plus 2 is 2. So our first point is 0, 2. That one should be pretty easy. Second one, we're going to plug in 1 wherever we see x. So y equals 4 times 1 plus 2. 4 times 1 is 4. Carry down our plus 2. A lot of kids are messing up on forgetting to bring in whatever number's being added or subtracted at the end. So make sure you don't forget this part. So we have y equals 4 plus 2, and 4 plus 2 is just 6. So we've got 0, 2, which is right here, and 1, 6. So our graph should look something like that. And yes, again, I know it's wobbly. All right. Now we've got y equals negative 2x plus 8. Once again, we need to get to 2 different points. Okay, I'll let Pamela choose the points this time. So 0 and 3. 0 is always a good pick. So I would strongly recommend using that one first because it's going to be the easiest, and then you can pick whatever you want for the second one. 3 is usually, or 1 is usually easier, but we'll do 3 this time just for fun. So y equals negative 2. We're replacing our x with 0 plus 8. So negative 2 times 0 is just 0 plus 8. Y equals 8. So our first point is 0, 8. We can go ahead and graph that right here. And then we're going to plug in 3 for x. So we have y equals negative 2 times 3 plus 8. Negative 2 times 3 is negative 6 plus 8. And negative 6 plus positive 8. Be careful with this one. That's going to give you positive 2. So we have the point 3, 2. And we're going to connect these something like this. And so it looks like our solution is right about here on this 1, 6 point. So we're thinking that maybe it's 1, 6 is our solution. We can check this by plugging these into both of these equations. So we know that 1, 6 is already on our green line because we already solved for that point. So we can just plug that into this and make sure it works. So in order to check that, we plug in 1 for x, y equals negative 2 times 1 plus 8. Negative 2 times 1 is negative 2 plus 8. Negative 2 plus 8 is in fact 6. So this does work for both of our equations, so we know that this point is our solution. So our final answer here would be the point 1, 6. Now that's probably one of the most complicated things that we do, or that we're doing in this unit. So if this one you're a little bit shaky about, that's okay. But again, it would be a good idea to stay after class today and get some extra practice. And then the last thing that we're going to talk about is solving a system of equations using substitution. So this is the really hard one that we've been doing the past couple of days. A lot of people have not tried any of the homework related to this. So if you haven't done that yet, please go take a shot at it when you get done today, because it's going to be really important to know how to do this. But in this case, we have the equation y equals 3x minus 4 and 2x minus y equals 1. So this equation isn't solved for any variable, so we don't want to use this as our substituting equation. We're going to use this one instead, and we're going to substitute y. So what we're going to do is put this in parentheses, this 3x minus 4. Here, I'll rewrite it like this. And we're just going to plug this in wherever we see y in this second equation. So we're going to write out our second equation just like normal, 2x minus, and then since this is a y, we're going to put in our stuff in parentheses. So 3x minus 4, and then we can finish the rest of the equation equals 1. Now, this is really important. Right here we have 2x minus, and then we have in parentheses 3x minus 4. When you have a minus in front of a parentheses like this, you have to distribute that symbol to both of the parts inside. So we've got 2x minus 3x, and then we have a minus negative 4. When you have minus negative 4 like this, that's the same as just plus 4. So we have 2x minus 3x plus 4 equals 1. Now we can start to solve this. So we can simplify 2x minus 3x, that's negative x, plus 4 equals 1. And then from here, we just need to solve for x. Easiest way is going to be to add x to both sides. Add x. That gives us 4 equals x plus 1. And then we're going to subtract 1 from both sides. So we should get x equals 3. Now that we've solved x equals 3, we can plug that into either equation here and solve this for y. So I'm going to go ahead and use equation 2. So we'll do 2, and then we're replacing x with our 3. Minus y equals 1. So we have 6 minus y equals 1. You can either do some basic arithmetic here, figure out that you have to subtract 5 from 6 to get 1. Or we can add y to both sides, solve it a little bit more formally. That'll give us 6 equals y plus 1, and we subtract 1 from both sides, and we get y equals 5. So now that we have our x and our y, we just write this as a point, and then we are done. And remember, points are always written x first and then y second. So I believe that's it for the review, that is. So if you're feeling good about all those different things, then you are welcome to go work on the review homework. It is due tomorrow, and like I said, it is very important to do it before the test tomorrow because it's going to show you how prepared you are. I would say whatever score you get on the review is probably a good indicator of what you're going to get on the quiz as well. They're pretty similar. They contain the same types of questions. So if you can do really well on the review, you'll do really well on the quiz. And if you're struggling with the review, you probably want to get some help before the quiz tomorrow.